Hello, this is College Strive doing some math today in geometry. We're looking at, we're going to apply congruence in triangles. So congruent figures. If two figures are congruent, then all their corresponding parts are congruent. So let's have triangle here, and let's go ahead and use the same. Now imagine if I drew those perfectly. And if I did, that means this side would be the same as this side. That side would be the same length as that side. And then the bottom side would also be the same. And then this angle here would be the same as that angle. And then this angle, double loop, and then triple loop. So all the corresponding parts are the same. So right now, if we wanted to prove that two figures were identical, we would need to show that all their sides are the same length, and we need to show that their inside angles, or their interior angles, are the same. So congruent statements. The statement naming two figures as congruent. So for example, triangle ABC is congruent to triangle DEF. That's just a congruent statement. So wherever triangle ABC is, DEF, they're the same. And then the third angles theorem. If two angles of one triangle are congruent to two angles of another triangle, that means the third angles have to be the same. So if I got, let's say here, oh, come on, arc, trying to draw the same triangle, it's not working. So if this is 50, and this is 60, and that's 50, and that's 60, let's call this point C and point F. So angle C has to be angle F. Okay. So properties of congruent triangles. So reflexive, symmetric, and transitive, those also apply here. So the reflexive property, triangle ABC, is congruent to itself. And sometimes they'll trick you. Instead of saying triangle ABC is congruent to triangle ABC, they'll say triangle CBA. That's the same triangle. Okay? Symmetric property. So this would be saying if triangle ABC was congruent to DEF, then you can swap them. Then triangle, what's going on? Back. Then triangle DEF is congruent to triangle ABC. Transitive property. So if triangle ABC is congruent to triangle DEF and triangle DEF is congruent to triangle JKL, then you can say triangle ABC is also congruent to triangle JKL. So if A leads to B and B leads to C, then A can go directly to C. So write a congruent statement for the triangles. Identify all corresponding congruent parts. Okay, so here's my congruent statement. Triangle ABC is congruent to triangle FGH. Now you got to make sure when you're writing your congruence statement that each of these letters match their corresponding part. So this A is at the corner of the right angle. So F should be the same position. So see how A is in the first position, and then we have B in the second, and then C in the third. F is in the first, G is in the second, H is in the third. So be careful when writing your congruence statements. Okay. And then we gotta write all the corresponding parts. So angle A is congruent to angle F. Angle B is congruent to angle G. Angle C is congruent to angle H. And then we got the sides. AB is congruent to the segment FG. So don't forget the bars above your head there. BC is congruent to GH. So line segments are congruent. Lengths are equal. So the AB without a bar means the length. AB, the segment, means congruent. Okay. Or I meant AB, AB without a bar means length. And then AB with a bar just means segment. Okay, the segment AB. So those are all the parts that we needed. We needed to show that the angles were congruent, and we needed to show that the sides were congruent. Okay, in the diagram, QRST is congruent to WXY. Okay, so find the value of X. So angle Q is 65 degrees. So angle Q is 65 degrees. X is next to W, or X is angle W. Angle Q is congruent to angle W. Okay, because angle Q is in the first position, that means W is in the first position. But if you can also take a look at the figure, it's just upside down, right? Flipped upside down. So 65 is equal to that 5x plus 5 there. So when I subtract 5 over, I'll get 60 equals 5x. So x equals 12. Now y is a side length, or actually the y is found in a side length. So we already figured out what x is. X is 12. Okay. And it's the side length WX. So WX is the first two. So we're going to look at QR. QR is 6. Okay? So 6 is equal to y minus 12. So I add 12 over and I'll get y equals 18. Okay. All right, now let's look at let's look at some more stuff. So use the same diagram for checkpoints 1 and 2, okay? Same diagram. So name all pairs of corresponding congruent parts. Okay. So angle F is congruent to angle S. Angle G is congruent to angle T. So I'm just doing position 1, position 1, position 2, position 2, position 3, which is angle H, is congruent to angle U, and then position 4, angle J, is congruent to angle B. And now we got to do all the side lengths. FG is congruent to ST. Don't forget about the bars. GH is congruent to TU. HJ is congruent to UV. And JF is congruent to VS. Okay. Checkpoint 2. Find the value of X and the measure G. Measure of angle G. Okay. So they're telling us that T, which is in the same position as G, so those are congruent. That means we can set them equal to each other. So I'm going to add 7 over here and get 2x equals 110. So x equals 55. Okay, we know what x is now, so we're going to plug it back in to find angle G. 2 times 55 minus 7, 110 minus 7 is equal to 103. Well, what was I thinking? Yeah, those angles are equal to each other, so you could have just, after you found x, you could have just said 103. Or you could have said 103 from the beginning, but either way, we proved it. Alright, example 4. Find the measure of angle V. Okay, measure of angle V. Okay, so let's look at angle SUT. So SUT is this 44 degrees. And then we have an intersection. And then we have angle VW. So I'm looking at this angle here. So that should also be 44 degrees because of vertical angles. So angle VW, because of vertical angles. So that's 44 degrees as well. And then they tell you that angle STU, the 66 degrees, is congruent to VWU. So this is 66. So we have 66 plus 44 plus angle V is equal to 180 degrees because there's a triangle here. And if you add up all the angles in the triangle, you'll get 180. So 66 plus 44 is 110 plus angle V equals 180. If I subtract that, angle V gives me 70 degrees. All right, let's look at a proof. All right. Okay, so I'm going to save some writing space for me. Statement, reason. Okay. And I'm going to put, so this should be your statement 1 or statement 1 through 4. But I'm going to combine all these into my first statement. So in this first statement here, I'm going to put FH is congruent to JH, FG is congruent to JG, and those two angles there are also congruent. And the reason for that is because they've been given to us. Okay? So all those given statements should appear either as your first statement or statements 1 through 4 because there's 4 of them. Okay, so let me erase what we're trying to prove here. There we go, statement, reason. Okay, so given goes down here. Okay, 2. So we want to prove that two triangles are congruent. So what options do we have? We need to show that all corresponding parts are the same. Okay? So they already told us FH is congruent to JH, and FG is congruent to JG. So we need the third side. So the third side is HG is congruent to HG. They both share the same side. So how do we show that I am myself? That's called reflexive property. Okay. So we now have all three sides. Now we need the third angle. Okay. So how do we show that the third angle is congruent? Well, at the beginning of the section, we read about the third angles theorem. So angle F is congruent to angle J. So that was called the third angles theorem. Okay. Now I've shown that all the angles are the same and all the sides are the same. Therefore, these triangles are congruent. Okay. Triangle JGH. So we have to write that if all corresponding sides and angles are congruent, then the triangles are congruent. Okay, so let's back up. Okay, so statement 1, you want to put in all your given. So FH is congruent to JH, FG is congruent to JG, angle FHG is congruent to JHJ, and angle FGH is congruent to angle JGH. Okay, and the reason for that is it's given to us. Okay, so we're trying to prove that two triangles are congruent. Our only option is to show that all sides are the same, or all corresponding sides are congruent, and all the corresponding angles are congruent. Okay, so they already gave us two pieces to the sides, and we're missing the third side. The third side is here, HG, but they both share it. They're both the same, so HG is congruent to HG. That's through the reflexive property. And then, so we had the three sides down. Now we're just missing the angles. And then by the third angles theorem, we're able to show that angle F here is indeed congruent to angle J, because if two angles of two triangles are congruent, then the third angles should all be as well. And now we can finally say that the two triangles are congruent because all corresponding sides and angles are congruent. Alright, E is the midpoint of AC and BD. Okay. So AE, so this one's going to be a long one. Statement, reason. Okay. E is the midpoint. Oh, this is statement 1, sorry. 1. He is the midpoint of AC and BD given. So what does it mean to be the midpoint? Well, what it means is AE is congruent to CE. Alright? This piece is congruent to that piece, because that's the midpoint. And then this piece is also congruent to that piece. So BE is congruent to ED. If a point is a midpoint, then it divides it into divides into two congruent segments. Okay, so we have two sides now. 3. AB is congruent to DC. Why? Because that little tick mark tells us. So that's actually given in diagram. Don't forget about the bars. Okay, so we have all three pieces now. Now we need to show the angles. Okay. So what else is given in the diagram? They tell us that AB is parallel to DC. That's what that arrowhead means. If those two lines are parallel, I can say, angle BAE is congruent to angle DCE. So BAE is congruent to DCE. And to show you that, okay, so in the last chapter, so here's my two parallel lines. Here's DC and AB. And if you remember, let's call this the transversal here. Okay, so I didn't make the rest of the triangle yet, but this is all we need. If I extend this line here from last chapter, this angle here, and, oh, actually, one second, pause. I messed up. So let me show you where I messed up at. So I said BAE, yeah, right there. Oh, right there. Oops. No, I was right. Okay. So parallel lines. DC. And then AB. I just drew the wrong transversal, is all. And let's say that's point E. So what we're saying is that this angle here is congruent to that angle. So if I extend this out, you can see that these are alternate interior angles from last chapter. So, if there are two parallel lines, so I'm going to shorthand this. If there's two parallel lines, then alternate interior angles are congruent. Okay. And then 5, we're going to say angle ABE is congruent to angle CDE. So ABE and CDE or you can call it angle B and angle D. Those angles for the same as 4. Those are alternate interior angles. And let me show you the reason again. So we have AB, DC. Actually, let's draw those a little bit more like that. So they're saying that this angle is congruent to that angle. Same reason. Alright, and then 2 more steps, because we need to figure out the last angle. So that would be these 2 central angles here. So angle DEC is congruent to angle AEB, and that's because of vertical angles. And then 1 more. So I think that was step 6, so this is 7, I think. Triangle ABE is congruent to triangle CDE, because if all corresponding parts of 2 triangles are congruent, then the triangles are congruent. And that's all I have for today.